So in the last class, just to summarize, we had discussed, we had started this sheet metal forming processes, right? It's a broad domain, uh, but you have a lot of processes to discuss, right? And then there are some other processes such as uh, so you have starting with your sheet metal forming process as in blanking, piercing, right? And several other secondary processes is bending of the sheet metal, right? To give it a final shape, right? A simple sheet is bent, right, to have a complex shape, if you want to call it. So that is their bending, and in terms of forming, you have either die forming, etc., right? And then you have drawing also, wire drawing, tube drawing, and coining as well. And there are other processes as hot and cold spinning. So all those come under the category of metal forming, especially if you are dealing with sheet metal, then we can call it sheet metal forming or stamping as well. So we had discussed what are the different what is the importance of sheet metal forming, and what are the products that are there that are formed, and for what industries or what sectors uh, of industry, as for example automobile, airplane, railway, to name a few. We had discussed the aluminum beverage can, what are the different processes involved, right? I need you to look at the different processes that we have: blanking, deep drawing, redrawing, and ironing, basically making that wall thickness consistent, and doming, necking. Now these are miscellaneous processes, but still, majority, I mean, you would see blanking, deep drawing, and as your primary processes. So now, and we also look at the stamp parts, right? This is specifically for the aerospace industry, as I can see, this part here, and but still, they're stamp parts, right? As for the dies for sheet metal processes, most press working operations perform with conventional punch and die tooling, right? So you have a punch, you have a die, because to be able to form that sheet metal, you need to have some tools. The equipment consists of basically punch and dies as the primary tooling, you could call it. Right? Conventional punch and die tooling is what we have been using sheet metal, right? Custom design for particular part. So if the part is customized, then you have to have the die and a punch specifically made for that, designed for that particular part. For example, a component may need to be mass produced, right? It has to be assembled in many places and many products. That component is required. What to do? You have to specifically make a die and a punch for that particular part, and this is usually the case. That it's not. This is generally, what do you call it? Especially when you're automating it, you make it specialized. Specialization of operations is one strategy being followed in automation, so that you can have mass production, and that too within less time, and therefore you can have that component as many number of times as you want, as many number of products that you want to be produced. So in that sense, you have to have a customized press for that. So customized punch, customized die, etc. So that is usually the case, but other cases are wherein you have a single press. You just change the punch and die setup, right? Basically batch production, you can call it. that you change the die and setup for each part that you want to produce. So for 10 components with of one part, you will use a die and punch for that particular in that particular general equipment. You'll fit that die and punch and then produce maybe 10 components out of it, and then another component with another design. Therefore, the die and punch is to be changed. You change the die and punch, suiting for that particular component. So that, and even the die and punch could be made in a sense that they can change. You can change the geometry of the die and punch, basically having some temporary connections so that you can use it for multiple parts, right? Let's say one component, there are two components, both have similar features, but there is some degree of change, or maybe it could be geometrical change, right? And therefore you require some other die and punch. But what is done is you make it compatible. I'm sorry, you make it flexible in the sense you make some temporary joints so that you can move some part of the die and punch so that it is suitable for stamping or pressing some other component, right? With some slight variation. So that's the difference. The term stamping die sometimes used for high production dies, right? So that is a general convention followed, that for high production, those dies have been traditionally known as stamping dies because they have been made for that particular manufacturing that particular component. As for the components of a punch and die for a blanking operation, let's say we are looking at, if we are looking at a blanking operation, the components for a punch and die, here you can see this is attached to press ram, basically the hydraulic press, right, which is responsible for giving the energy to this punch ultimately, is attached to this press ram. That is, that hydraulic energy is received from this ram and is transferred to this punch holder and therefore to the punch ultimately. So that energy is being transferred here, and then this punch holder, as the name suggests, will hold the punch. You have a punch here, and this punch holder has to slide down for the punch to move up and down. So how does this punch holder slides up and down? Through this, there are something called guide pins, or in very large setup presses you have columns, right, or arms, if that is also the terminology. So that those arms are basically, this punch holder will slide on those arms, and bushing, etc. Those are auxiliary components. But here you have the stripper, the stripped stock, basically the stock that is fed, right? As we said, hot rolling is one process, right? That basically you roll sheets, I mean, from higher thicknesses to lower thicknesses. You want to roll them, compress it, so that the dimensions decrease, the thickness decrease specifically, and therefore the grain orientation also changes. But those are dense now, and they are of lesser thickness, the thickness that we want. So that is fed, that sheet is fed in form of strip. Basically, that sheet is fed, and then this punch is responsible for cutting out material from that strip. So you even have some stops here, basically to if that strip was to continuously move, this punch wouldn't be able to take out the material, or take basically this stamp this blank, right? Cut out, shear out this blank from the sheet. So once this stop is basically responsible for stopping that strip at a particular spot, so that this punch can come down and remove this black portion. And then this will allow the stop would go inside and then allow the sheet to come in, and then again it steps up so that the punch can do its job. die holder, basically to hold the die. Here you have the die, as you can see, and this is tapered. You will see why. It's basically clearance, right? Otherwise the material would be either damaged because of the friction, right, between the die and the blank which is coming out, and so that is why the taper is done. Press base, right? So this is what a blanking operation is, right? I think we'll have another slide for blanking operation, but in a sense a blanking operation is where you are removing metal from sheets, right? So that removed material is what is your useful uh, byproduct. If blank is your useful byproduct, the removed material is your useful uh, byproduct, then that's what you call blank, right? Piercing is the opposite of that. The the removed material is not the byproduct, it's actually scrap. The one, the base strip which was there, stock, right? Strip stock, that is your byproduct in piercing, right? So you can see here stamping die, right? As I was talking about, those arms or pillars or columns, if you want to call them, they are responsible for sliding of this total uh, structure so that the punch can move down, right? And therefore we can have the stamping operation be performed, right? So two things are being shown here. The first one being a progressive die, right? So 4 punches, as you can see, if this is my finished part, right? If this is the part that I am that is intended, right? That this we have to fabricate this component. How to do that? You follow some steps here. As you can see, associated strip development. That firstly, this semi-notch is created, and then the square punch, and then the punch. It removes this circular portion, and then parting. Right? Basically, you cut it off. So how do we do this? Here you see progressive die in the sense there are each punch, you can see 4 punches. Each punch is responsible for doing a particular task. So first punch, as you can see, will remove this semi-notch, right? He'll create the semi-notch. And the second one is a square punch. It is responsible for creating that square, removing that square circle. I'm sorry, the square portion from the sheet or the strip. So progressively the part is formed. That's why it is called progressive die, right? The lower shoe, or basically the lower, this is your lower die. The lower shoe in the sense it supports the die, right? The upper shoe basically slides down, right? This is fixed. So the punch would be sliding down. So when the strip moves to the left, this is basically you can see the orientation goes from right to the left. You have this finished part, right? Each punch is responsible for doing a particular task so that you can have a component very faster. Unlike sending them to individual punches, you are trying to incorporate all those features. Those features are basically fabricated, or those features are executed in one die, right? That's why we call it progressive die. So here is another example of a progressive die. You can see different steps. As for example, if you start from here, you have a circular part, and then you make some projections on it, and then another projections, right? Slowly and steadily, it receives features from different punches because of the profile of the punch, right? So that's what is progressive die. Here another example of a progressively stamped part. This is your end product. This is where we start. First hole, right? You remove this material, and then these 4 slots, and then you bend them, right? Bend it here at that point. And then what? Uh, some extra features again, right? So even bending is not done. I mean, all bending is not done at once. Different features are bent in different positions. There's a circular cutout, and then those holes, right? Yes, this cutout as well. As you can see, that circular cutout is made, outer profile and then the inner profile. So that's your final product. Okay, this sheet has been stamped by a progressive die, showing the series of operations from right to left. Right? As we go from right to left, we have those operations being performed, and we can see how the features are incorporated. Components of typical mechanical drive stamping press, right? So if this is the drive which is driving it, right? I mean, the flywheel, of course, is there. So the ram would go up and down, right? Bolster plate, basically responsible for clamping. So uh, that bolster plate is responsible for clamping the die, right? And the frame bed, etc. All these are structural components, right? So these are examples of stamping machines. You can see some of them are quite big, right? You require those electric drives to basically provide the energy to the punch, right? The upper part of the stamping machine. So 3 major categories we can make when talking about the sheet metal stamping processes. First one is cutting, right? As it involves shearing, we know it's shearing to separate large sheets or cut part perimeters to make holes in sheets, right? Perimeters in the sense we know what is perimeter, right? You have a profile. So basically cutting, right? You're trying to remove some material, you're trying to either part or uh, parting is done basically to remove the finished part from the sheet. That is also cutting, isn't it? And even in between, like for example, if I want to incorporate a feature as a hole, that there is a hole that I want to make. How do I do that? To remove material. So that is cutting, right? So all these processes that I talked about, they encompass cutting. As for forming, you are trying to not remove material, you are trying to shape it. As the name suggests, you are trying to form it. So two major categories again: bending, that is straightening the sheet around a straight axis, right? You have an axis about which you will bend, isn't it? So that's why we're calling straining, basically deforming, right? Strain is a measure of deformation. Straining sheet around a straight axis, and then drawing, forming of sheet metal into convex or concave shapes. That is basically using your punch and dies we were talking about, right? If you're what we have looked at until now is cutting, right? In those previous slides, we looked at cutting, basically removing of material. But there were other processes like bending also incorporated. Like for example here, right? From here to here, you are having that bend. So that comes under bending, right? Forming in the sense you are trying to I'm sorry, drawing in the sense you're trying to have a kind of compressive action on the sheet, right? So that it can be either made convex or concave. You see here, cutting, shearing between two sharp cutting edges. You have this die. So you have this die upon which you have this material, right, which you want to cut. So the punch will slide down, basically shear it from here. So shearing between two sharp cutting edges, as you can see, this edge between the punch and the die. So shearing of sheet metal between two cutting edges just before the punch contacts the wood. So this is before the punches contact the wood. I believe we have other slides as well. The next process is, yes. So once it contacts the sheet, then you have the onset of plastic deformation. So the punch begins to push into work, causing plastic deformation. So it basically tries to move this material down. Right? So there is plastic deformation involved. And then penetration, it penetrates the component more and more, right? Once compresses and penetrates into work. So before it was only compression, right? There was deformation, but there was no penetration. Then it did not penetrate. When does it penetrate? When actually the material gives in and it fractures, right? From the very top, isn't it? Because that's where the punch is contacting it, or even could be here. But basically it compresses first, right? And so long as the material withstands it, that compressive force, it doesn't fail. But when it tries to give in more, it basically, the punch is allowed to penetrate the sheet. So therefore it causes a smooth cut surface, right? As you can see here, it fractures at some point, as I was talking about. It compresses first, and then basically that plastic deformation continues and until a point that it fractures, penetrates and then fractures, right? So fracture is initiated at the opposing cutting edges, which separate the sheet. Opposing edges, one is your punch and the other is die. So that basically travels across this point to that point. Shearing, blanking, and piercing, right? All these are cutting operations. Three principal operations in press working that cut sheet metal are shearing, blanking, and piercing or punching. Both are same, but you have those two terms to define the same process, right? So either punching or piercing, but the other two categories are blanking and shearing. As for shearing, it's a sheet metal cutting operation along a straight line between two cutting edges, right? You're trying to shear it off, as we have seen in the last slide. Typically used to cut large sheet into smaller sections for subsequent operations, right? So large sheet being cut into smaller sections, or even remover of those material, right, inside that strip. So that is also shearing. You can see here. So this A is the side view of the shearing operation. If you look at it from the front, it will look like this. But you're not able to understand how does this shear. It may, I mean, one may look at this diagram and conclude that this is basically trying to compress it. But when you look at it from the side, you will see that it is not exactly, they are not exactly in line. These two, sorry, punch and die are not in line. Therefore, they are basically offset from one another. When the punch moves down, the die will, I mean, the material will rest on the die because there is no resting point or resting surface for this portion of the sheet. It has to shear off, right? So all the way through, not just this point at this particular cross section, but all the way through. As for blanking and punching, blanking the sheet metal cutting to separate piece from surrounding stock, right? So you have a stock material and you want to remove some material, right? Cut piece is the desired part called a blank. As I was talking about, depends on which is your desired part, right? The byproduct, as I was saying. So the desired part is the cut piece, the piece which has been cut right now. And that is called a blanking process. And the part which is cut is called blank. Right? The part which is actually come out of that sheet, it's called a blank. As punching, the sheet metal cutting, it is similar to blanking, except cut piece is scrap and called a slug, right? So the cut piece is scrap, right? But what was remaining after the cut piece is what is the desired part. Remaining stock is the desired part, right? Doubts so far? No doubts. So as for blanking, you see, it's a metal fabrication step, in which this workpiece is cut from its base metal sheet, right? The scrap, the strip, basically. Downward stroke, the downward stroke of the punch shears the outline of the piece, right? Basically, shearing, right? That's the dominant mode of deformation that is happening here. That is yielding the result, right? That's shearing. So the downward stroke of the punch shears the outline of the workpiece, as we know. The outline is basically where the punch and the sheet are contacting. I'm sorry. The Yes, the outer profile of the punch will contact the outline of the workpiece, right? The workpiece where it contacts, the punch where it contacts the sheet metal, right? The outer profile, what is formed, is the outline, as we call it. So cutout is a blank, as we know. Usually the first step in the metal fabrication process, right? Because if you want to form a particular shape, you have to have a primary shape. How do you get a primary shape? Basically, the primary flat piece, so you want to call it. How do you get the primary flat piece? You have to cut it from some stock of material, right? From some stock material. So this is why we are calling it the first step, and it makes the workpiece more manageable to handle for succeeding operations, as we know. So we can't just move that strip to every place. What we can do is take out some card from that strip, decide the profile accordingly, right? And then that profile which you've taken out will now be uh, sent to succeeding operations. For example, form it, right? Bend it, and then give it some shape, have some recess on it, create some holes, create some projections, etc. Right? The excess material is scrapped and then recycled, right? So the excess material that is there, it can be scrapped and then maybe recycled, in the sense it may be remelted again, right? Depends on the case. As for punching or piercing, as we have said, it works in a similar fashion to blanking. How? Because it is basically uh, shearing operation as well, right? The dominant mode of deformation is shearing. Process of boring small shapes, example, holes in the workpiece by application of a shearing force. So for example, uh, in blanking, you had that blank which was removed as a useful product, right? But in some components, it may be so required that a hole has to be created, for example. Then after removing of the hole, the component, the earlier component is what is we desire, that we want to perform more operations on it. And basically the blank which was removed is not the desired output. So therefore, you have that the turnaround, you can say, from blanking to punching or piercing, right? So a portion of the blank is cut from the blank and discarded after rejection, right? As we know, punching may be combined with the blanking step in a single downward stroke of the punch. So punching may be combined with the blanking step as well, right? So if that remove component is to be used somewhere else, then it may be combined, you can say, in that sense, right? Or you could have a progressive die kind of setup where in one step you are doing this thing and the other step is simultaneously doing that. As you can see here, in blanking, when you have removed that metal, this is the blank part, right? This is called blanking because we require this. But this same blank part, again it was punched, and here this becomes your desired output now. If this is what we want, a square with, I mean, a sheet of metal with a circular hole in the center, right? This is what we want. Then we have to make a hole. After this process, once this is removed, this goes here. If you want to remove this material, you have to what you call scrap out or use a punch